All right, good afternoon or evening, AP Calculus students. So this is the video that I promised you for the DeltaMath, and I'm hoping to do this on a more consistent basis so you can trust that you will go in your email, find in your inbox daily videos where I go through the homework assignment. Now, on your DeltaMath, we do have quite a few sections. Again, this is a 2-day assignment. Actually, I don't know if I mentioned, but because it's a 2-day assignment, I'm probably going to make it worth 20 points, right? This is the first section, finding the integrals from the given areas. All right, so this is how we do that. Let's take a look. If I'm looking at this problem, I note that my integral goes from -8 to 6, right? So I would personally just mentally sort of mark this down from -8 to 6. And if I were to shade that area, I'm shading this area, and actually, if I'm being slightly more effective, I'm going to shade these in red because these areas are negative. All right, then B, is a positive area, right? Okay, so my integral from -8 to 6 of f of x dx is going to be equal to, well, let's think about this. First, I'm going to add area A. Now, area A is going to be, let's see, area A is 13, right? However, it is -13 actually, right? Because the area is below the curve. Cool. I am also going to add in area B, which is 16, and it is positive area, so I'll say plus 16. All right, finally, my final area that I'm going to take into account is area C, which they said is 12, but it is, again, negative area because it's below the curve. Right? So that's how I would take into account and add these up for my integral. And if I add them up, let's see, it's -25 plus 16. So my end answer should be -9. All right. So that is how you would solve this first section, the problems. Cool. Should be pretty straightforward. Cool. Now let's move on to the second section where I'm going to do one of these problems. Now they asked me to find the integral again. So from 0 to 7, let's see. So I start at 0 and I go to 7. I'm going to shade this area. Remember, it's the area between the curve and the x-axis. So the curve is right there. The x-axis is there. Then I'm going to shade up to 7. Right. And now this area here is negative. So I'm writing it in red. All right. So let's talk about this area for my integral. This looks like a triangle to me, so I'm going to use my triangle formula, 1/2 base times height. That's equal to 1/2. My base is 4, my height is 3. Excellent. Then the red area, to me, this looks like a trapezoid. You also have the option, if you want to, right? If you want to, you could also turn this into a rectangle and a triangle. Either way, if you use your trapezoid formula or you separate into two shapes, either way is fine. But I'm going to use a trapezoid in this case. And my trapezoid formula, which is admittedly a bit harder to remember, is C plus D divided by 2 times W. Or my base, however you want to think about it. So C and D are my two lengths. So in this case, the way the trapezoid is oriented, I'm actually label C as this and D is that. It's the sides, the side of the trapezoids which have like different sides, if that makes sense. So C, notice how this side is longer than D. So I know those are my two lengths. Excellent. Then my W would be this. W. So again, it might be easier to use triangles and rectangles because it is oriented kind of weird and it might be easier to make a mistake. But regardless, I will follow this. So my C goes from 4 to, let's see, that looks like 7, right? So my C is 3 plus D, that is 2 units. So 3 plus 2 divided by 2 times my width. In this case, my width goes from here to here. That is a width of 3. All right, cool. So let's simplify this. 3 plus 2 sorry, 3 plus 2 divided by 2 times 3. I'll just mentally note that is 15 over 2. All right, now let's solve the top part here. 1/2 times 4 times 3, that is equal to 6. All right, cool. So I might just be like 6 plus 15 over 2. However, remember this, I wrote it in red because this counts as negative area. So my actual answer is going to be based off 6 minus 15 over 2. If I were to write this in simplest form, I'm guessing I need to combine these. So I'm going to write 6. I can rewrite 6 as 12 over 2 minus 15 over 2. This allows me to actually combine these into a single fraction. And this fraction turns into negative 3 over 2. So that would be your final answer, negative 3 over 2. All right. So again, take it slow. There's only certain, like we only know a couple area formulas, right? So apply those area formulas, note whether it's positive or negative, and that is it, essentially. All right, let's move on to the definite integral graph, level 3. All right, so this is the one that I did an example of in class, but I could definitely see how it still might be confusing. So let's go from -6, so I'm going to note -6 to 4, so right here. All right, I'm going to shade my area. Okay, beginning, it's a tiny positive area. You can see that it's a positive triangle. That's it. The rest of this area, however, all looks negative, right? This area is negative and negative, right? Now, if I were to divide this into shapes, just so I have an idea of what I'm doing, right? Looks like this shape I could divide into a triangle. And this shape here is basically a rectangle, but there's a circle sort of cut out of it. So it's a rectangle minus, like the rectangle's there, minus the circle. So we'll get into how I would calculate for that. So first, let's calculate for the area of this tiny triangle here. So I'll zoom in a little bit. That triangle would follow the area equation 1/2 base times height. That's equal to 1/2. My base is like 1, and my height also looks like 1. Right? You could count each one as like 1 block. So my overall area is 1/2. Excellent. Now, the area of this triangle. Note that I am, actually, yeah, let's just calculate for the area of the triangle. So it's also 1/2 base height. So 1/2, my base, looks like I go from -5 to -2. So my base is 3. And my height is also 3. All right, if I were to simplify that, that looks like it is 9 over 2. Right, yeah, cool. Finally, this is probably the toughest shape. It is a rectangle minus half a circle. So I'm going to write that equation out before I plug in anything. So a rectangle would be length width. Then I'm cutting out, right, half of a circle. So I'm cutting out 1/2 pi r squared. That's 1/2 of a circle. Cool. Now I can plug in my values here. So length width of this rectangle, let's see, my length, I go from 0 to, that looks like -3. So my length is 3. My width is, that looks like 6 boxes. So it's going to be 6 minus 1/2 pi. All right, my radius of the circle is 3. So 3 squared. Cool. So if I were to simplify this, I guess I could do that now. That's 3 times 6 is 18 minus, that should simplify to 9 over 2 pi. All right, cool. Now the last part is I'm combining these, right? But remember, my blue is considered positive area, positive. My red, both of these are considered negative. Right, so I need to take that into account, right? So what I was about to say earlier is note, first I calculate for everything as if it's positive. Then at the very last step, I take into account whether it's actually positive or negative. So for example, this 1/2, I'm going to keep it as 1/2, right? Because it's positive. So 1/2. Cool. Next, 9/2. I'm going to subtract this area, right? So I'm going to minus 9/2 because it is negative area. Actually, I'll write that in red. So minus 9/2. Cool. Also, this 18 minus 9 over 2 pi, that's the entire area of this. Don't be fooled by this negative. I have not subtracted it yet, right? So I need to subtract also this area. So it's minus, and I'm going to put this whole thing in parentheses, minus 18 minus 9 over 2 pi. Right? Because I'm taking this whole area. This would be the positive area, but I need to subtract it. So that's why I did minus and then put it in parentheses. All right, so after this, we're just going to simplify. 1/2 minus 9 over 2, that's minus 8 over 2. Cool. Then minus, this is in parentheses, so I'm just going to distribute it. So minus 18. The two negatives actually turns it into plus 9 over 2 pi. Cool, let's keep on simplifying this. This is minus 4 minus 18 plus 9 over 2 pi, which means my final answer should be negative 22 plus 9 over 2 pi. They want it in the simplest form that you can get, and that is effectively the most simple form. All right, let's continue. Next section, find the integral from given areas with properties. All right, so this looks super similar to the first section. However, they ask a couple properties. So first, let's take a look. They asked for the integral from -1. So I'm going to say -1 to 8. Right? -1 to 8. I could shade all this, right? Shade all of this, and then shade all of this. Right? So what are my areas? The first one, 15. So that's really -15. My area here, 6 is positive. And then my bottom area is -6, right? That's also negative. However, what do I note about this? They said the absolute value of the function, which means this function, if I were to take the absolute value, it would be reflected up like this. Right? Everything is now just simply positive. It's reflected back up. So all of these, I'm going to take the absolute value of them. Absolute value of 15, absolute value of 6, absolute value of -6. This just simply turns all the areas positive. That's essentially what it does, right? So I could write this, all areas are positive. All right, so absolute value of -15 is going to be 15, absolute value of 6 is 6, absolute value of -6 is 6. So I just add all these up. That should give me a value of 27. That would be my final answer. 27 is my final answer. All right, let's see. They ask a few other properties, so let's try to answer this one. This one I liked, this question. It's sort of fun, right? So first thing I would notice, they asked for when my integral is equal to 0. Well, one thing I'll notice, we learned a 0 property today, right? So that's what my mind would jump to. And just right off the bat, I should know that if my integral starts at -5, if I want to get 0, how do I get 0? Well, I would just write my integral so it goes from -5 and it ends at -5. Remember, if it stays at the same number, so it starts at -5, if I start at -5 and end at -5, there's no area, right? So I don't go anywhere. So that means one option is b would be equal to -5. This could be -5, right? All right, let's think if there's any other options, right? So I'm starting at -5 and I want to go somewhere, b, right? Well, I'll notice, let's say if I imagine myself, b is, let's say it's -4, right? So -4. Well, I would have accumulated this area, right? So that's not going to be 0, right? Because my integral is not going to be worth something. However, if I keep on imagining, right, -3, my integral would be 6. So that's not going to be 0. But what if I go from -5 and I end at 1? What do I notice? Well, I notice that I have some integral, which is a positive area, but also I have accumulated negative area as well. So +6 and -6. So it's going to be equal to 0. Hence, I have another option. My answer B could be -1, right? Because that would also get me 0. So -5 to -1 would also get me 0, which is sort of tricky because you have to see that. That's not a property necessarily that we learned. So my answer here would be b is equal to -5, comma, -1. That would be what you put in DeltaMath. All right, final section. So this is, I believe there were 8 questions on this part. This is mainly focused on the lesson that we learned today, right? An assortment of different integral properties. So let's see if we can figure out, this one's a lot of like puzzling, like mixing and matching, flipping stuff to see if you can get to the right answer. So they tell me my integral from 1 to 6 is 2. Okay, sure. Integral from 6 to -6 is 8. First of all, this looks a little weird to me because the higher number is on the bottom. And notice it should always be on the lower number should be on the bottom, right? 1 to 6, that's normal. This one's sort of off, but okay. We have tools to deal with that. What is the value of the integral from -6 to 1? All right. So notice, yeah, -6 to 1, I want to get to this integral. Well, how might I do that? All right. First thing that I want to do is notice -6 is at the bottom here. So I'm going to take this integral where -6 is at the top. I'm going to flip it, right? I'm going to do a reversal property. So I can match this. -6 is at the bottom, right? That's a good place to have my -6. So if I flip it, so my integral is from -6 to 6. What happens when I flip the two numbers? What would happen to my 8? If you look at your reversal property, you should know that it's now going to be -8, right? Now, so my reversal, my integral is -8. And I already know, I'm just rewriting this, my integral from 1 to 6 is equal to 2. All right. Now, if I know my integral from -6 to 6 is -8, and my integral from 1 to 6 is 2, right? So essentially, what I'm saying is, I know my integral from -6 to 6. I also know my integral from 1 to 6. Right? I know both of these. Well, if I want my integral from -6 to 1, I can just take my integral from -6 to 6, and then I can cancel out this part. I'm going to cancel this part out, the integral from 1 to 6. Right? So to do that, I'm going to write this up here actually. I'm going to take my integral from -6 to 6, and I'm going to subtract my integral from 1 to 6. Right? That's me canceling it out. What I'm left with is then my integral from -6 to just 1. Right? I'm left with this part, which is exactly what I want. Right? So if I follow that property, my integral from -6 to 6 is -8, minus my integral from 1 to 6, so that's -2. That's equal to -10. Right, so my answer here is going to be -10. And this one was actually, admittedly, I think, sort of difficult because you need to mix and match until you can put the right pieces together, essentially. All right. I wrote a couple more here. So yeah, these all use different properties. So yeah, might be a multiple day sort of thing. All right. Let f be a continuous function such that the integral from 4 to 6 is equal to -1. The integral from 2 to 6 is equal to 9. What's the integral from 4 to 2? All right, okay. So first thing I'll notice, this 4 and 2, I need to do some sort of reversal, right? Because usually it should be 2 to 4. That would be ideal to have, right? So let's take a look at what else I'm given. I know my integral from 4 to 6. So again, with this number line, I know my integral from 4 to 6. I also know my integral from 2 to 6. 2 to 6, right? And clearly, I'm focused on the integral in some way from 2 to 4. So what I want to do is take my integral from 2 to 6 and cancel out this part. Cancel out the integral from 4 to 6. So I can do that. I'm going to take my integral from 2 to 6, and I'm going to subtract the part that's from 4 to 6. So integral from 2 to 6 minus the integral from 4 to 6. That leaves me with my integral from 2 to 4, which I can just quickly flip to get to my answer. right? So let's write that. My integral from 2 to 6 is 9. I'm going to subtract my integral from 4 to 6, which they tell me is -1. That leaves me with my integral from 2 to 4, which would be 9 minus -1 is positive 10. Right, so my integral from 2 to 4 is positive 10. All right, excellent. So I'm going to say my integral from 2 to 4 is equal to positive 10. However, that's not my final answer yet because note, they asked me for my integral from 4 to 2. They flipped them. Right? So I just have to flip my answer from positive to negative. So my integral from 4 to 2 is not positive 10, it's negative 10. So again, my answer happens to be negative 10, and that's basically just random chance, but negative 10. All right, I'm going to do two more. Let f be a continuous function such that my integral from -9 to 5 is -2, and -1 to -9 is 8. What is the value from -1 to 5 of fx plus 3 dx? All right, so I'm going to start based on my answer, right? So what I would do here is, first I will note, this looks sort of complicated, but remember, we have an addition property. Don't overthink it. Simply, this is my integral from -1 to 5 of f of x, and I can separate the integral. So plus my integral from -1 to 5 of 3. Right? Excellent. Now, we can take steps to start solving this, right? First of all, I'm going to say this we have a property for, right? Really, if you remember, right? If you remember and you look at our graph, right? This is just, let's say, a line at 3, right? This is 3. I go from -1 to 5. If you remember in class, really, we're just finding the area of a rectangle, right? So what we learned in class is this is really just length times width, or specifically the equation we used in class was k times b minus a, which is length times width, right? So what is my length? Well, my length is basically the height of this rectangle. My height is 3 times my width is from 5 to -1, so 5 minus -1. So that's equal to 3 times 6. Essentially, my integral is 18 of this part here. Right, so I'll double underline it, right? The integral from -1 to 5 is 18. Cool, so I have that part figured out. I need to figure out this part next, right? So let's figure out what this integral is going to be. Well, what am I given? I'm given my integral from -9 to 5 is equal to -2. I'm also given my integral from -1 to -9. All right. So, this is sort of confusing because, let's see. So, sorry, this is 8. I don't like the fact that this -1 is higher, right? This should be flipped. So I'm going to flip these. So -9 to -1, that means it's no longer 8, it's -8, right? So what do I know here? I know my integral from -9 to -1. And I also know my integral from -9 to 5, right? I'm trying to figure out my integral from -1 to 5. So I want to eliminate this part, right? So I can do that. I'm going to take my integral. So I'll write this down here. I'm going to take my integral from -9 to 5, and I'm going to subtract this part. Right? I just cancel it out by subtracting it. So minus my integral from -9 to -1. All right. So what does that equal to? My integral from -9 to 5 is -2. Minus my integral from -9 to -1, which I calculated for, is -8. Minus -8. So that's equal to 6. So essentially what I'm saying is my integral from, I'm left with my integral from -1 to 5 is equal to 6. So this integral is equal to 6. This integral is equal to 6. So it turns out it's 6 plus 18. 6 plus 18, right? That means my final answer is 24. All right. last section here. Okay, my integral from -3 to 10 of 1/3 f of x, I have this to work with. Well, first I'm going to look at this 1/3 and not panic. Remember, we learned that I can just take the constant out. So integral from -3 to 10 of f of x dx. So whatever my answer is, I'm just going to multiply it by 1/3. Right, so I'm going to focus just on my integral first, from -3 to 10. Well, to figure out my integral from -3 to 10, what am I given? I'm given my integral from -2 to 10, -2 to 10. And I'm also given my integral from -2 to -3. Notice how these numbers are flipped. They should not be written this way. So I'm going to flip this. Really what it's saying is that my integral is from -3 to -2, and instead of -6, it should be +6. All right. So if I'm trying to figure out my integral from -3 to 10, my integral from -3 to 10 is simply going to be these two sections, and I'm going to add them together nicely, right? So I'm going to take my integral from -3 to -2, which is right here. Integral from -3 to -2. I'm going to add it to the integral from 2 to 10, or sorry, from -2 to 10, right, which is given to me right here. So that's integral from -2 to 10. All right. That means my integral -3 to -2, we said that was 6, plus my integral from -2 to 10 is 3. So that's equal to, I'll rewrite this, -3 to 10, it's equal to 9. All right, so let me rewrite my integral, right? It's 1/3 times my integral is 9. So that's going to be 3. 3 would be my final answer. All right, I know that was a lot of problems. Hopefully you don't have to, once you start getting the hang of it, you'll be able to just write it out really quick, possibly even do it mentally, although I definitely would not recommend that at the beginning. Please let me know if you have any questions. We are probably going to continue practicing this, so don't rate too much if you are having trouble. But make sure you get your homework done because there's going to be more coming. All right, that is it, and have a good night. Bye, everyone.